All right, so the topic for this video is going to be about composite surface area. And our essential question here says, how is surface area calculated for composite solids? So a little background information here to get us started. It says composite solids are made up of more than one solid. In order to calculate the surface area of a composite solid, one needs to identify the individual solids that it is made of, be mindful of faces that are not exposed. The use of lateral surface area formulas can be helpful. Okay, so just remember in general here that surface area is the amount of space that is exposed on your solid, right? Like if you're trying to paint this thing, how much paint would it take to cover the entire surface, right? So if we're looking at example one here, we can see that it's kind of two prisms stacked on top of each other. We kind of got the smaller one and then the larger one on the bottom. Let's go ahead and just take a look at the top one first. Let's just consider this top one. So I'll just kind of say over here, top prism. Now we need to ask ourselves, what is this top prism, or what are the faces of this top prism are actually exposed, right? Like if we were painting this thing, how many of the sides would we paint? And the answer is we would paint kind of 5 of them. It's everything other than the bottom of it, right? The bottom of it is sitting on top of that larger prism, so we wouldn't need to paint the bottom of it if we were painting it. So here's what I'm going to say. The normal surface area, total surface area formula is pH plus 2b. Now, remember what all of these things stand for. The P is the perimeter of the base. So we'll say that this side of it is the base, so that would be our P. The H is the height of the prism, which would be this too. And the B would be the area of the base, which would be this part. Now, normally with a prism, there are 2 bases, right? So there would also be this one, but we don't want that because that side of it is not exposed. So I will not be doing 2B, I will only be doing B because only that top base is exposed, the bottom one is not exposed. So with that in mind, let's kind of figure out what's going on here. So for the P, for the perimeter, I would be adding up 3 plus, see how we've got this 5 down here, which would mean that this is 5, which would mean this is 5. So all the way up to this part would also be 5. So kind of had to do a little searching to find out what that side would be, but that's 3 plus 5 plus 3 plus 5, which would be 16. We already said that our H is 2, and our B, the area of the base, is that rectangle, which would be 3 times 5, which would be 15. So all in all here, for the surface area of the top prism, I'm going to be doing 16, I'll say S equals, S for surface area. I'll be doing 16 times 2 plus 15. So let me type that in here into my calculator. 16 times 2 plus 15 is 47. Okay, so that takes care of the top prism. Now let's find the bottom one. Now the bottom prism is going to be a little bit trickier. We know that prisms in general are pH plus 2b, right? But is every side of this bottom prism exposed? And the answer is kind of. Sure, every face on that prism is exposed, but there is one part that is being covered up, right? We're not going to be painting the entirety of this bottom prism. So let's just kind of think about this. If we did the pH plus 2b again, we could say that the P is the perimeter down here. The H, the height of it would be this 4 over here, plus 2 times the area of the base. The area of the base would be down here. And that should make sense because we do have 2 of these bases, right? We do have this one as well. Even this part over here would be exposed. But there's this part, right? The bottom of the top prism is being covered up, or is covering up part of the top of the bottom prism, if that makes sense. So what we need to do is subtract the area of the base from the top prism, because that part is covering up our bottom prism. So I'm going to subtract 15, right? Which was the area of the base from the bottom one, or from the top one. So hopefully that makes sense, because that top prism is covering up a portion of the bottom prism. So my formula here for the bottom prism is going to be pH plus 2b minus 15, because there's 15 square centimeters that are being covered up from the bottom one. So let's run through that. So perimeter of the base for the bottom one here would be 5 plus 8 plus 5 plus 8. That's 26. The height of the bottom one is 4. And then the area of the base for the bottom one is 5 times 8, which is 40. So what do I need to do here? I need to do 26. Let me say S equals 26 times 4 plus 2 times 40 minus 15. Let me type that in there. 26 times 4 plus 2 times 40 minus 15. Getting 169. Okay, so we have 169 for the bottom one. We have 47 for the top one. Let's add them up. 47 plus 169 is 216, and this will be centimeters squared. All right, that one's kind of tricky. Hopefully that made sense. I bet if something didn't, it was this 15 part right there. That part was pretty tricky. I'll try to just kind of explain it one more time. Just remember that that 15 came from the fact that the top prism was sitting on the bottom one and was covering up a portion of the bottom one. And so we had to remove that from the total surface area formula for the bottom one because that part of it was not exposed. And the area of that region was 3 times 5 is 15. That's why we had to subtract it from the bottom one. Okay, let's go to the inside. Try a few more. All right, so what do we got going on here? Find the surface area of the composite solid. Looks like we got ourselves a little cone sitting on top of a cylinder. All right, so let's talk about the cone. First question, is every side of the cone exposed? The answer is no. The circle is not exposed because the circle on the bottom, the base of that cone, is being covered up by the cylinder. So I will not be doing the entirety, the total surface area for the cylinder or for the cone. I will only be doing the lateral surface area formula, which is pi RL. The lateral surface area just takes care of the sides. It does not include the base. We don't want the base because the base is not exposed. So what are our numbers here? Looks like our radius would just be 5. Our slant height would be 8. So we are just going to do pi times 5 times 8. And let's see what we get here. I'm getting 125.7, and I will be rounding to the nearest tenth if I have to round. All right, so now cylinder time. Now let's ask ourselves the same question here. Is every side of the cylinder exposed? And the answer is no, right? Because the top circle, the top base, is being covered up by that cone. So normal total surface area formula for a cylinder is 2 pi RH plus 2 pi r squared. I'm not going to do the lateral surface area formula because I do want the bottom of the cylinder, right? Now, what shape is the top of the cylinder and the bottom of the cylinder? It is a circle. And how do you find the area of a circle? It is pi r squared. So I do not want 2 pi r squareds because I do not have 2 exposed circles. I only want a single pi r squared, right? I'll make a little note here that I only want 1 circle. So what are our numbers? Well, our radius stayed the same, right? Our radius is still 5, but this time the height will be the 4 there. So I'm going to do 2 pi 5 times 4 plus pi times 5 squared. We'll type that in. 2 pi 5 times 4 plus pi 5 squared. I am getting 204.2. So now I'll take the 125.7 plus the 204.2. 125.7 plus 204.2, and I'm going to get 329.9 centimeters squared. So you got to be careful with those bases, specifically if only one side is being exposed, because you can't do the lateral, you can't do the total, you kind of got to adjust them. All right, let's take a look at this one. What do we got here? We got a rectangular prism and a triangular prism. Let's talk about that triangular prism first. I think that's the weirder one. Okay, so to find a normal prism, we do pH plus 2b. And let's think about that for a second. So the P would be the perimeter of the triangle, right? Because this is a triangular prism. So that would be perimeter of the triangle times the height of the triangle. And the height of the triangle is how far it is going from left to right or from triangle to triangle. So that would be this or this, one of those, right? Which I believe is 6. We can see it over on this side also. Times or plus 2 times the area of the base, which would be the area of the triangle there. Now, is every side of that triangular prism exposed? The answer is no, because the triangular prism is kind of connected on one of the lateral sides to this rectangular prism. So we do need to subtract that side. Now, what side am I talking about again? I'm talking about this side here, right? That side is being covered up. So what is that side? That side would be 6 times 3. Right, because it's a rectangle over there. So weird formula. I know, weird formula. but we have to subtract that side that is being covered up. So let's run through that real fast. What is our P? What is our perimeter? That is 3 plus 4 plus 5, which is 12. Our H, the height of the thing was 6. We said that. The area of the base, it is a triangle, so we need to do 1/2 base times height, because that would be the right angle in there. That is a 3, 4, 5 right triangle, so that's got to be a right angle right there. Half of 12 is 6. Okay, so let's plug that in now. So that would be 12 times 6 plus 2 times 6 minus 6 times 3. Okay, just one more time here. That's 12. That's the 6 plus 2 times the area of the base minus the part of the prism that's being covered up. So let me plug that all in and we'll see what we get here. 12 times 6 plus 2 times 6 minus 6 times 3. I'm getting 66. Now let's do the rectangular prism. We can think about the rectangular prism a couple different ways. Let's go ahead. I'm just going to go ahead and kind of think about it going kind of bottom to top. So the general formula here is that pH plus 2b again. Our perimeter would be the perimeter down here. And how would we find that? That would be 12 plus 6 plus 12 plus 6, which would be 36. Our height would be this 3 right there. And what else do we need? We need the area of the base. Sure. So the area of the base, I'll just reuse blue here. Area of the base would be the 12 times 6. Which is 72. But every side of this rectangular prism is not exposed, because remember that kind of left face over there is being covered up by the triangular prism, so I do need to subtract that 6 times 3 again, because that part is being exposed. Remember, anytime two prisms, or not even prisms, anytime two solids are stuck together, you got to subtract that common part from both of them, because it's being covered up for both of them. So now if I plug all that in, let's see what happens here. We're going to do 12. No, I'm sorry, not 12. 36 is the perimeter, so 36 times the height, which is 3, plus 2 times the area of the base, which was 72, minus the 6 times 3. Okay, so 36 times 3 plus 2 times 72 minus 6 times 3. I'm getting 234. Okay, so we had a 66. Oops, sorry. We had a 66, we have a 234. Let's add them together. And that is 300 centimeters squared. Cool. Okay, let's keep going. What do we got here? Find the surface area of the composite solid. Prism is a regular triangular prism. Okay, so it looks like on this one we've got a shape inside of a shape, which means that we've kind of removed this thing, right? We've kind of like drilled a hole through it. So let's talk about the triangular prism first. Okay, so regular triangular prisms formula, pH plus 2b. But before we dive into what is what, let's just think about what's been removed from the triangular prism. And the part that's been removed from the triangular prism is these two circles, right? That spot, which used to be filled in the triangular prism, is no longer filled. So we're not going to do pH plus 2b. We're going to do pH plus 2b minus 2 pi r squared, because we got to remove the two circles that are missing from it. So now that we kind of understand that part, let's go ahead and figure out what's going on here. So for the P, for the perimeter, we need to do the perimeter of the triangle. Which would be 3 times 14, because it's a regular one, right? So all those sides are the same. So 3 times 14 is 42. For the height of the thing, we can see that is 6. Now the B. Now this is where it gets a little bit trickier. To find the area of a triangle, we need to do 1/2 base times height. Or we could do 1/2 AP because it is a regular triangle. What would be easier for us right now? I think it would probably be easier for us just to do 1/2 base times height. If we imagine the height kind of coming down like this, since this is a regular equilateral triangle, this part would be 7, right? Because it gets cut in half. And this angle right there is a 60-degree angle. So that is a 30, 60, 90 triangle, which means that the height of our triangle is 7 root 3, right? Because of the 30, 60, 90 rules. So I'm going to do 1/2 times 14 times 7 root 3. Let's see what we get when we do that. Getting 84.9. And that would be the area of the base, which would be all of this stuff here, right? Okay, so the only thing that we are missing here is just our radius to plug in, which should be 2, because the whole thing's 4. All right, so I think we got everything we need. Let's go ahead and plug some stuff in. We're going to do 42 times 6 plus 2 times the area of the base, which was at 84.9, minus 2 pi 2 squared. Type that all in. 42 times 6 plus 2 times 84.9 minus 2 pi 2 squared. I'm getting 396.7 for the triangular prism. Now we got the cylinder. Now this part's a little bit strange, but if we imagine what parts of the cylinder we would actually need to paint, well, it's really only the sides of it, right? Because the top and the bottom, that's where the hole is, but the inner part is now an exposed surface. And those lateral walls there, we just need to do the lateral surface area formula, which is just 2 pi RH, which we already have both of those. We already know what the radius is. That was 2. We already know what the height is, too. Shouldn't do that in yellow, I should do that in green. Right? The height of this cylinder is the same as the height of the prism, which was 6. So we just need to do 2 pi 2 times 6. 2 pi 2 times 6. I'm getting 75.4. So we just need to do 396.7 plus 75.4. 396.7 plus 75.4. Let me see here. Getting 472.1 centimeters squared. Okay, and the last one here says find the surface area of the composite solid. The pyramid is a square pyramid. Okay, let's start with the prism. Prism formula, pH plus 2B. But if we're thinking about how much from this prism is exposed, I would say, well, the perimeter would be the bottom down here. 4 sides, if this is a square pyramid, it's a square prism, so that would just be 10 times 4, which is 40. The height is clearly 5. And then the area of the base, that would be down here. That would be 10 times 10, which would be 100. Now, the only issue is that we don't have a top of this thing, right? So we don't need 2B because we don't have 2 bases. We only have the bottom base. So let's go ahead and plug that stuff in. We're going to do 40 times 5 plus 100. 40 times 5 plus 100 is 300. And now let's talk about the pyramid. Would we need to paint all the sides of the pyramid? The answer is no. We would only need to paint the lateral sides, right? Because that pyramid doesn't have a base. So we just need to paint the lateral sides, which is just 1/2 PL. Okay, so 1/2 PL. The P would be the same as the perimeter of the prism. So the P would still be, oops, don't want to do that. The P would still be 40. But the L's a little tricky here. So remember, the slant height is supposed to go like this. The slant height's supposed to go like that. So how are we going to figure that part out? Well, what I'm going to recommend we kind of do is kind of imagine, let's imagine a right triangle kind of going like this to the center of the pyramid and out. Because that would form a little right triangle where the slant height would be the hypotenuse. Now, this part here, the height of the prism would still be the height of the pyramid, right? So that part would be 5. And then the part kind of going the apothem of the square, I guess you could think about it that way, would also need to be 5 since that's going halfway across and the whole way across is 10. So if those two legs are both 5, then we could do the Pythagorean theorem, we could say 5 squared plus 5 squared equals L squared. 25 plus 25 equals L squared. That's 50 equals L squared. Simplify it, and we should get that L is 5 square root 2, which some of you guys might have noticed because it's a 45, 45, 90 triangle once we kind of dive into it a little bit there. So our slant height ends up being 5 root 2. So what we need to do for the pyramid then is 1/2 times 40 times 5 square root 2. And I'm getting 141.4. So we got to do 300 plus 141.4. And that should give us, not 5, that should give us 441.4 centimeters squared. Cool, cool, cool. All right, I know that some of these can be tricky. Hopefully that went pretty well, and it is your turn to try to. You got a cone inside of a cylinder, and you got a cylinder inside of a prism. So give those a shot, and then come back to check to see how you did. Okay, so as far as the cylinder goes here, I'm just going to be doing 2 pi RH plus pi r squared. I'm not going to be doing 2 pi r squared because we only have one circle that is being exposed. When I plug stuff in there, that should be 2 times pi times 9 times 12 plus pi times 9 squared. That 9, of course, is coming from the radius. So let me see what I get when I do that part. 2 pi 9 12 plus pi 9 squared. I'm getting 933.1. And then for the cone, I'm just going to be doing pi RL, not plus pi r squared, because we don't need the circle because that part's not exposed, right? So this should just be pi times 9 times 15. And for that, I'm getting 424.1. So let me take my 933.1, add it to my 424.1. 933.1 plus 424.1 is giving me 1357.2 centimeters squared. Cool, cool, cool. And then this guy here, let's talk about that prism first. For the prism, I'm going to be doing pH plus 2b minus 2 pi r squared. I'm subtracting the 2 pi r squareds because there's those two circles that I need to remove from my prism. So let's find some things here. Perimeter of the base looks like it's 6868, so the perimeter should be 28. The height of the thing, height of the prism is 5. Area of the base, area of this part down there would be 6 times 8, which would be 48. And then what else do I need? Just the radius. The radius would be 2. So with all that in mind, we are going to be doing perimeter, which was 28 times, not 3, times 5. 28 times 5 plus 2 times 48 minus 2 pi 2 squared. That should give me the surface area of the prism. Let me type this in here. And I'm getting 210.9 for the prism. So now the cylinder, we don't need the top and bottom of the cylinder because those are holes, right? We just need the lateral sides. So that would just be 2 pi RH. We already know what the R and the H is, right? Because the H, the height of the cylinder is the same as the height of the prism. So this will just be 2 times pi times 2 times 5. 2 times pi times 2 times 5. I'm getting 62.8. So we're going to take that 210.9. We're going to add the 62.8. And we should have ourselves a final answer here. I'm getting 273.7 centimeters squared. All right. Hope that went well for y'all, and that's going to wrap this video up.